much. Good morning, good afternoon, or good evening, depending upon where you are in the world. I happen to live in Scottsdale, Arizona, in the southwest of the United States, and I'm the specialist for video surveillance for Qumulo. I'd just like to talk today a little bit about a scalable file system for video surveillance. And before I do that, I'm going to have to start talking about video surveillance so everyone understands more about it. When we talk about video surveillance, we have to start looking at some minimum requirements to make sure that video surveillance is successful today with our changing requirements and our changing environment. The whole point of video surveillance is to protect property and to protect people. It must be fault tolerant, and you should not lose any video. And there are organizations that have requirements that they not lose one frame of video. The storage must be easy to administer, or you run into the danger of it not being fault tolerant. And you wouldn't be able to scale without downtime to the video surveillance, which is not allowed. You should not cause any disruptions because of hardware or software failures. And storage should accommodate the changing camera needs. In our modern environment, we're changing the cameras all the time because we want longer retention times. How long do you keep the video? There are sometimes legal requirements that say that you have to have video for 7 days or 14 days or 30 days. In the state of Arizona, we have a requirement that it must be 270 days for any video recorded by any agency of the state government. So you can see that storage requirements become critical. Greater camera density, casinos, for instance, hotels, universities are all going to 8 megapixel cameras, which is also called 4K cameras. And faster frame rates. Why? Because AI works better when the picture resolution is completely crystal. And I will show you some examples of that as I go through the presentation. So all storage is driven by the cameras. The resolution, as I said, is increasing. The frame rates are increasing mainly because of AI. Complexity in a scene, and I'll show you some examples. When you have an empty hallway versus people walking in a hallway, the data rate changes. And there are legal requirements to keep things longer. So for instance, if you're looking at a camera that's 720p, 720 pixels, and it's running at 10 frames per second, it's almost impossible for a human operator to identify a person who runs across the screen. If they walk, it's no problem. If they run, there's a big problem. You can see with the resolution that I have 3 pictures, one with 60 pixels per frame, 90 pixels per frame, and 150 pixels per frame. A human operator probably would have no problem with any of these pictures, but AI could not identify the license plate except probably, it may be able to do 2 or 3. I said all 3, but it would never be able to tell the state. And you can see that the state in the US is Pennsylvania, but AI would have a problem probably with 1 and 2, and in number 3, it would be crystal clear. Also, AI would not be able to identify the person and do facial recognition on 1 and 2, because look at the circles around the eyes, even in number 2, which looks pretty clear. The problem is that once you have people of color where their skin is a little darker, you would not be able to identify them because of the shading. You have to go to a very dense camera for AI to work properly. A lot of people would say, well, then I will get cameras with very good compression. Well, compression can only get you so far. You can see now, here's a person with low compression. It is still compressed, and one where you turn up the compression on a 1080p camera. And you could tell that it's very hard to determine the eyes, and also do they have a mustache or do they have a beard? And you'll see that in the left photo, you can see the male's, what we call in English, the Adam's apple, here, and you do not see it on the one on the right. So again, AI would not be able to work here. Frame rate is very important. Walking is never a problem with lower frame rates, but running is. You can see here that even a human operator, if that person is running across the frame at 10 frames per second, they would be out of that frame or out of that picture in 2 to 3 frames. And then with 30 frames per second, it would take much longer and you'd be able to identify them. Scene complexity. If I'm looking at a school hallway and I see it on Sunday, it only transmits at 0.3 or basically 300 kilobits per second versus 2.5 megabits per second when there are students in the hallway. So what does this all mean? It all means that we have to worry about storage in terms of being able to accept all of these changing requirements for video surveillance. I apologize for the picture. I did a configuration of 100 cameras of 1080p, and I put them in at 15 days for 10, 20, and 30 frames per second. So I have 10 here where my cursor is moving, 20 below it, 30, and then down on the bottom right, I changed it so that I didn't do 15 days of retention, but 30. Now you can see the requirements for storage just on something so simple as 100 1080p cameras. I require 32 terabytes. But if I double the frames, I double the storage. If I triple the frames, I triple the storage. And if I increase the retention, I double the storage again. So you always look at video surveillance as something that every change that you make will double the storage. So what is the market for video surveillance? Well, I always laugh and say it's everywhere. But when we look at where we've been successful with HPE and Qumulo, it's city, state, and federal governments. This will change in your countries, of course. It's schools, what we would call K through 12, kindergarten through 12th grade, and then the universities, the police, jails and detention facilities, water and power companies. We have one here in the United States, in my state of Arizona, where a city government is monitoring their power and their water, and also their public transportation with 2 different Qumulo clusters, one for the public, for the power and water, and one for the public transportation. In other words, all the buses, the airports, any sports venue, you can see the picture in the bottom right, any casino, malls or retail shopping, and of course, warehouses and manufacturing. So I'm going to talk about one where AI is very prevalent. AI is very big in this environment, and it's becoming much larger. And that is manufacturing. This is not something that most people would think of as video surveillance. When we talk about video surveillance, we think of monitoring people and automobiles driving through a facility. We don't think of manufacturing, but video surveillance could have a big role in manufacturing. You see a manufacturing plant on the screen. This manufacturing plant is about 1 million square meters in size. And it's one of the largest in the world. And they make 5.5 million batteries per day for automobiles, for electric automobiles. Now, that is 100% automated. There are robots that are making those batteries, and they are going to use video surveillance with AI so that they take a picture of a battery, and that battery would be a perfect battery, and then they would take a picture of every battery that is being manufactured, and compare it against the perfect battery and see if there are defects. And if there are, then it moves it to the side and a human operator will look at the battery and test it and put it back if it's good. And if it's not, it takes it out. The whole point is to make sure that you have better quality so that what comes out the other end of the manufacturing plant is as close to 100% of quality as that you can get. And so this is a good use for video surveillance with AI. So what is the opportunity? The market is growing dramatically. Today, it is about 40 billion euros. We're looking at it to be, or the industry is saying it will be about 63 billion euros by 2023. The storage market is looking to grow from about 4 billion euros today to 5.5 billion. That's a growth of 1.5 billion euros in only 2 more years. In 2018, there were 130 million high definition cameras, and those are improving and increasing every year. To give you an idea, a medium video surveillance site would be about 1 petabyte, and large sites like airports, casinos, or sports stadiums can easily exceed 7 petabytes. I had an RFP here in the United States, a request for proposal for a casino that was 14 days of retention, and it was 14 petabytes. That was 5,000 cameras. So you can see how large some of the video surveillance can grow. And then AI analytics is very small today by euro volume, if you will, or euro size, but it's expected to grow to 2.5 billion in the next 2 years. So let's talk a little bit about the architecture. I'm going to specifically talk about Milestone today. And I'll move my cursor and hopefully you can see it. In the top right of the picture, we have management servers. And those servers know about all of the assets in the environment. An asset is the recording servers and the cameras, and also all the video walls. So the management server plays a role in understanding where everything is. It writes that data into a SQL server. And then there is an analytics server for doing AI and a smart wall. And that usually is on its own network, which is 10 gig or faster. And then you have recording servers. The cameras at the bottom go into a recording server, and the recording server takes that camera data and then writes it to storage, and then informs the management server which cameras are on which recording server. The management server does not know about every piece of video. That is known at the recording server. The management server only knows about the cameras and the recording servers, not the video. So you can have 20, 30, 40, 50, 100, 200 recording servers based upon how large your environment is. If you have poor storage, you will have video surveillance failures. So this one right here is storing locally. You can see the recording server. And if you'll see in the bottom right of a recording server, I have a little picture of a disk drive. And that disk drive is the recording server writing local on the recording server. This requires lots of administration, and people are very expensive because I have to create a recording server with enough disk to do RAID, to do disk rebuilds, to worry about the amount of cameras and the changing camera requirements. If I change these cameras from 1080p to say 4 megapixel or 6 megapixel or 4K, then that changes that storage, and I have to go to every recording server and I have to change out the disk internally. So things are very heavy on administration and very low on performance. So as I said, you record to every disk on every recording server. Another way today is, and a lot of people are using this, is that they use what's called scale-up storage, where that storage sits on your 10 gig network and the recording server writes across the 10 gig network to that scale-up storage. Again, it is very administrative heavy. People are very expensive, and you have to have lots of volumes. As you can see here, most scale-up storage has a limitation on the volume size. So when a volume fills up, then an administrator must become involved and must determine, how do I move the data on that volume to another volume? And they have to then take down the recording server, have it fail over, increase the volume size, move the data from the old volume to the new volume. You can see that there is a lot of administration. If a disk drive breaks here, it is very slow, and it takes about 40% of all of the CPU to do the disk rebuild. So you have to build your system so that you can plan for disk rebuilds by not putting more than 40 or more than 60% load on the system, so that you can preserve it for disk rebuilds. A disk rebuild is about 1 hour per terabyte. If you have 18 terabyte drives, it's 18 hours. An OS upgrade can take longer than 30 minutes. Can your video surveillance system handle a 30-minute outage? I don't think so. There's a new paradigm that we want to talk about using Qumulo storage. And Qumulo is a clustered node-based storage system with a minimum of 4 nodes to form the cluster. Each node is either a hybrid, meaning it has some amount of SSD or NVMe and spinning disk, or you can have nodes that are 100% flash. All the blocks are distributed across all the nodes. When I write to any node, it distributes it automatically across all the nodes so that every node fills up evenly. We use erasure coding. Erasure coding provides a much better failure or fault tolerance than any RAID system in existence today. With erasure coding, I could take a single drive failure, a dual drive failure, a triple drive failure, a quadruple drive failure, and then I could also lose an entire node or 2 nodes, so that all of the drives in the node go away. RAID could not handle that, because RAID looks at single drive failures or dual drive failures. It never looks at entire units going away. And real-time analytics will give me visibility to my data so that I can make informed decisions on the performance and the growth of the system. So using Qumulo, I now put this back in the system. And what I can do is I can grow on the fly. As you can see here, I added 3 nodes, and I never shut down the video surveillance. I have 1 volume and 1 mount point. So I never have to worry about an administrator figuring out which recording server goes to which node or which volume. It's all 1 volume and 1 namespace. And as I said, the fault tolerance is built in. I could lose 1 node or 2 nodes or 3 nodes, depending upon the size of the cluster and all of the drives in those nodes. And everything stays up and running. I can do an OS upgrade in about 30 seconds, and all of the modern video surveillance systems can handle outages of about 1 minute, where it records on the recording server. And then if the storage comes back within that 1 minute, then the recording server puts everything out onto the storage without losing even 1 frame. And finally, we have built-in real-time analytics. So I can look at the performance per camera, the storage per camera, and I can know when I need more storage. So let's just look at what is possible with the Qumulo system. So first off, I can do direct storage. If I have a recording server that's in the same data center as the Qumulo, meaning on the same network segment, then I could write direct to the Qumulo with the recording server. I could also, if I have a recording server that's, say, on the university campus, and I put the recording server near the cameras, I can record from the cameras into local storage for 1 hour, 2 hours, 3 hours, whatever I wish to do. And then after that period, I would move all of the assets, all of the video, and aggregate them or put them all together on the Qumulo cluster. Why would we do this? Well, the big reason is fault tolerance. I want to be able to worry about recording server failures, network failures. The only thing I can't protect against is a camera failure, but everyone in video surveillance understands a camera could fail. But generally, if a recording server fails, I would have a memory card in the camera to record the video. When the recording server comes back, then that camera would speak to the recording server and it would give everything that's on the memory stick. I could also have a failover recording server so that I don't have to have a memory stick. I could have the failover recording server take over. And then all of that video goes to the Qumulo cluster. But if the network goes down for the main data center, then the recording server continues to record and it can keep doing that without losing any video. So I'm at the point right now, I've actually gone fairly quickly through this, where I would have a demonstration, and I'd be happy to do that now. But first, I'm going to go back to Marta and also the other people in Qumulo and see if there are any questions.
So hi, Mike. Not so far. There are a few comments from Michal, which is a good summary of how does it work. So just imagine fast, reliable, and protected storage. You know, like Lego pieces that bring you the scalability, capacity, and performance as you need it. It's quite like this acronym, how you compare this. Very interesting case on the manufacturing for quality purposes. I think that's something we can see more and more with our customers or with our partners. So maybe later on you can sort of touch maybe a little bit more on the quality management from the cameras, or how can you even better use the video surveillance for quality purposes in manufacturing.
Very good, thank you. So let me go. You don't need to see my email here. Let me, I just need to, there we go. So can you see that screen okay, everybody? Marta, looks good?
Yes, it looks good.
Okay, so here we have our UI for the Qumulo. And this UI allows me to look at the entire operation of the cluster. I will first start by showing you that this cluster is 20 nodes of our Qumulo product called the K144. This is 144 terabytes per node. I must first apologize. This is an HPE/Qumulo presentation, but in my lab, I do not have a large HPE cluster. I have 4-node, 5-node, and 6-node HPE clusters. So I needed to do a very large demonstration for a customer with 3,000 cameras, which I'm going to show you today. So I needed something larger. So I used our own K144. If I look at the screen here, I see that on the left, I have a green checkbox. That means that everything is healthy and all the nodes are talking to each other and acting as one cluster. That cluster is 2.2 petabytes in size, and I am currently using 1.3 petabytes, and I have 866 terabytes left, and it is 61% full. You can see that I've got data protection and it's all there, it's all automatic. And the other thing that is very interesting is all of the data is encrypted. There is no option in Qumulo to turn this off. We believe very strongly that customers want protected data, so we encrypt all the data at rest automatically in our systems. So whenever you build the cluster, all the data is encrypted. If I were to look at any node, I would see the way it would look as if I walked into the data center and I pulled out the node and I looked inside. So you can see that we have a drawer, and in that drawer of the node, I have 12 times 12 terabyte drives. 12 times 12 is 144, hence the name K144. But you can also see that I have 3 times 800 gigabyte SSDs. And in a hybrid node, we use that for writing and for reading for the cache. So because we have one volume and one global namespace, we would take all of the drives and we would make them into one big drive. So I have 20 nodes times 3 SSDs. This means that I have 60 SSDs in one big drive. And I haven't done the math, so I apologize. 20 times 12 disk drives is one big drive of spinning disk. So as data comes in, it gets written to all of the nodes and all of the SSDs. In other words, we distribute that data across the SSDs. And as the SSDs get full, then we move those blocks to the spinning disk, and that provides very high performance for writing. And then when we need to read, we read directly from the spinning disk and give to the user or to video surveillance. But if you touch those blocks 3, 4, 5 times, then we will bring them back to the SSDs as they become hotter. And that way we can provide faster performance for the reads as well. If we look at the system itself, you'll see that, again, how big is the storage? I say how many nodes I have. I can tell you how many files are in the file system and how many directories, and are they growing or shrinking? So you can see right now, I have a little caret that's going down, and I'm shrinking the file system because the video surveillance is doing deletion of old videos that are beyond the retention time. So I have a retention of 20 days, and when it moves the data, it actually goes and deletes the old data, and then that creates space to write the new data. I have 3 histograms, IOPS, throughput, and latency, and I can look at any period of time and see what the performance is. Down here, I could change the sizing so that I could come along and look at 8 a.m. in the morning and look at this peak on the screen. And you'll see over on the right side that it says I was writing at 6.6 gigabytes per second at this point in time. I can move this out and I can look at every hour and see what was happening. I could come down now and look at the distribution for the performance. So over the last 24 hours, what was the performance for reading? What was the performance for writing? And what is it currently? I'm currently reading at 800 megabytes per second. I'm currently writing at 738 megabytes per second. If I come down to client activity, I can see how many clients are connected to every node. Our cluster is not built with an idea of a master and a worker. It's built with the idea of 2 nodes that are peers. All the nodes are peers and they all do the same work. So there is no master, there is no worker. On the most active clients, I can see exactly which ones are doing the most IOPS and which ones are doing the most throughput. If I come to the bottom, I can see the growth over 72 hours in terms of snapshots for data protection, data growth, or shrinkage. In this case, it's growing. How much metadata, and overall, how much has it grown? And then I can look at which directories are growing the fastest. Because of video surveillance, most of this data will be in a single directory, so you'll see that. Let's go over to the video surveillance. For some of you who understand Milestone, you will see here that I have a menu on the left that shows me all of the functions that I can do, and I have selected recording servers, and I have here 30 recording servers that are actually recording 100 cameras each, so that gives me 3,000 cameras. Now, all of the images are the same because I am using a camera simulator. I do not have 3,000 cameras in our corporate environment in Seattle. I am actually using a camera simulator that Milestone provides, and this can simulate any size camera. I am currently doing 1080p cameras, which are 2 megapixel, and I'm recording at 30 frames per second. The first thing I did was, if you remember my drawing, I'm assuming in this benchmark or in this demonstration that every recording server is not where the storage is. So I am recording here into tier 1, which is this tier right here. I'll double click and I say that where the database is and where the recording should go. It should go to a local D drive on the recording server. And I want it to only retain the data for 1 hour. Then I have this next tier, which uses a UNC path for SMB, which is the network protocol for Windows, which Qumulo uses, as well as NFS for Linux and Unix. And I'm using that UNC path to point to any one of those 20 nodes, or I could have it go and do an automatic round robin where I point to one specific name, and then the cluster along with DNS will distribute that load evenly across all of the nodes. I say how much storage I want to use, and then I give it the retention time. So what happens is this data for these 100 cameras comes into the first tier, and then at the top of the hour, it all gets moved to the Qumulo and aggregated there. So this way, if I have the Qumulo here and it starts to grow, where I am now looking at, I have 866 terabytes free. Let's say that this now becomes 95% full as a cluster, or 98% full. We can use our clusters above 85 and 90%. Most vendors do not allow this. We can use it all the way to 100% full. Let's say that I want to grow this, then all I would do, based upon my demonstration that I did earlier with my slides, is I would add node 21, 22, and 23, or just one node or 2 nodes. How many nodes that I want, and add them, and the cluster would automatically add them and load balance the data from the original 20 to be even across all 23 nodes. But video surveillance never stops. It keeps right on running. Everything here would never see any difference. It would keep running, your videos would keep running, and you would be fault tolerant. And at the same time, this storage would go from 98% full down to about 60% full if I added 4 nodes. And then you could just keep going and you would never worry about the storage growth. Just keep growing it on the fly. Now, with analytics, I could look at every directory in the system and I could see how big they are and who's connected to them. I have a directory for every single recording server, and you can see right here as I go through, you'll see on the left exactly how large they are. They're 47 terabytes. It's 2% of the entire cluster. Since we only have one volume and one global namespace, I can tell the percentage of the entire storage for every directory. There are 224,000 subdirectories and 4.2 million files. excuse me, there is one client, which makes sense because every recording server has its own directory. And then what are the open files? Right now, I'm not transferring any data. So the only thing that is open is the directory itself. I could look at every client and see the performance of every client. You'll see that it is not ready to transmit yet. So there is no data from any recording server, except I created right here recording server 2 and 12, where what I'm doing is I am moving the database from one location on the cluster to another. This is something that you do in video surveillance if you want to be able to basically move the data from one cluster to another. I did this so that I could show you the load of it running. And you could actually go and open this and see every file that is open and whether it's being deleted or whether it's being transferred. And so I am moving it from RS2 to RS2 new, and I can show you the performance of what is happening there. I can look at every single open file, and I can see the performance of every open file. And then when I open them, I can see who the user is who's doing it. So I can see exactly who has it. I can look at the storage itself. I really have one directory, but when I click, I see every recording server, and I can see the size by just putting my cursor there. I could also go into them, and then I can see every camera. So this is every camera. And then I can see the camera database, and then I can see the blocks for every camera, so that I can see exactly what the data is on every camera and the growth of that data as it gets added to the cluster. And then finally, I can also look over an entire year at the growth of the storage. So for instance, I can look at hour by hour for 72 hours, and I can see exactly how much the storage has grown every hour or shrunk. I can look at day by day for the last 30 days. And you can see where I started my demonstration and then I deleted it because I wasn't happy with my configuration. Then I started it again. And it's been running for about 27 days. And then I can look at week by week. And again, here's where you can see I started and I deleted everything. And now I've been running for about 3 weeks or 3.5 weeks, something like that. So you can actually go and you can look at the entire growth of the system over that period of time. And for instance, a month ago on January 24th, I used 797 terabytes. And then right about here where I restarted it on February 1, I had 13 terabytes. And you can see the growth every single day, all the way up to today, where we have 1.3 petabytes. I could also look at snapshots if I want to protect everything. And here I created a demonstration where I have recording server 15, and I have a snapshot of the data so I can recover it if anything happens. And I created a policy that says, I want to be able to snapshot that every 60 minutes for the next 24 hours. Excuse me. And I want to keep them for 2 days. So that means that if I'm taking them every hour, I would have 48 snapshots for that directory. We are allowed to have 40,000 snapshots in our system. So if I come back, you can see exactly where I'm looking, and you can see that the data growth is very large on the tier for the Qumulo and very small on the first tier. And the way that you look at that, because it's 1 hour, is come here and look at the cameras. So I'm looking at a live view, just looking at my time here, making sure we're good. I'm looking at a live view of 6 cameras across 6 recording servers. And let's go into playback mode. And you should see basically no difference. It's not playing back right now, but let's go and pick a time that's a bit older. Let's look at yesterday. Okay. What is today? The 23rd. And I want to go from 5 in the morning to say 5 in the evening. and I want to click OK. And now what I want to do is I want to be able to play that. And so now you're going to see that I'm playing that at 30 frames per second, and that's all coming off the Qumulo. Go look. Now, interestingly enough, those first two are still doing the writes or the moves of the database at about 600 megabytes per second or 800 megabytes per second. And then look at these next 6 of them. Look at how low the throughput is, because I'm only looking at one camera, and I could prove that by saying, here's all the blocks that are the indexes in the database and the blocks that are open. But I'm doing the data at about 300 kilobits per second, which is about right for a 1080p camera to stream at 30 frames per second. And so you can see that right there, and it's coming off the Qumulo. So this, again, a good pause point for any questions. We're about 15 minutes before the top of the hour. Marta?
Yes, thank you, Mike, and you're absolutely right. So we have a few questions in the chat. I would kindly ask you to raise those questions in the Q&A box so we can answer them properly. So maybe I start with the one that was the first, which is using erasure coding. What is the overhead should we expect?
Erasure coding will typically, for instance, on a 2 petabyte system, we will lose about 10% or thereabouts of the storage to erasure coding. So you would figure about 200 terabytes. If you want more protection, then you'll lose a little bit more. For instance, if I want to protect against 3 drive failures simultaneously and or 1 node at the same time, then it's about 200 terabytes for that 2 petabytes. If I want to protect against 3 node failures simultaneously, then it's about 350 terabytes or about 15% overhead in order to give you that additional failure domain. The performance really does not change. I can have higher protection with no performance loss. It's just storage. I hope that answered the question. If it didn't, please ask it again in the Q&A.
Yeah, thank you. Then the second one will be, what is the typical sizing? What are the typical sizing metrics?
So we must always have 4 nodes to start a cluster. When I looked at here for this cluster, I have 20 nodes. And the reason I have 20 nodes is because in video surveillance, you want to protect, not only you want to also record, also record the cameras and also be able to have AI or human operators look at the cameras. And you want to also potentially have disk or node failures where we would rebuild. And you want to preserve about 20% of the performance for disk rebuilds or node rebuilds for a protection. So what I typically say is that you should use about 60% of the performance of any node for writing and reserve 40% for the reading and the rebuilding. And I hope that makes sense to everyone, because video surveillance is predominantly writing into disk. And if no human or AI looks at it, you're only preserving it for legal reasons, where maybe someone is robbed in a parking lot in a university, then some operator would call up the video and look at the screen and go, oh, it happened on February 11th at 11 in the morning. I will go to that and look, and then that is still predominantly a write workflow. I don't believe that most video surveillance today does that. Most people want to be able to have video walls or operators looking at the video or AI looking at the video to compare it. So as I said, you want to build for 60% of the performance of any node so that you can reserve the rest. Now, how do you know what the performance is? Qumulo has a sizing tool that will tell you the performance of any type of node, whether that node be Qumulo hardware or HPE hardware. Here, we're more concerned about HPE hardware running Qumulo software. And we have published numbers on what that performance is, and you should size for 60% of that number in order to preserve the rest. If you don't have access to that, please talk to your Qumulo SE and they can help you get access to that tool, or they can provide the numbers for you. Thank you.
So there are a couple of others, but they've been mostly answered. I think one of our partners raised interesting question, or maybe a statement, is obviously they face more into the competition of Ceph or Supermicro or a lot of independent QNAP or StyleNAS appliances, and they're having difficulties to persuade the customer to request something more when just SMB is enough for their requirements. So how would you, approach maybe such customer? Because things are changing drastically nowadays. The cameras types are changing, the requirements from the customer, maybe the time of storing the videos. So just from your point of view.
Well, so I can tell you where we've been successful and where we have not been. When a customer comes to you and says, I have a certain budget and that budget is very low, then I don't want to say they're not concerned about their security, but to them, generally security is a secondary issue. It is not a primary issue. If you get to places like city and state governments, universities, casinos, shopping malls, sports stadiums, security is a primary concern. And in that case, you don't want to go to a QNAP, a Synology, a Microsoft environment, or local disk. You want things where you are not going to have performance problems. You are not going to lose the video. You are not going to have to take downtime because of administrators having to worry about the storage or changing the storage. Anything you do to an environment, from the storage all the way up to a camera, affects video surveillance. So any change that you make could potentially cause video surveillance to go down, and you don't want that to happen. You want fault tolerance from the camera to the storage, and any changes you make on the storage have to be invisible to video surveillance, so that video surveillance keeps right on running. If I come along here and I want to be able to, for instance, add more storage to the Qumulo, take a snapshot of the data, replicate it to another cluster, there isn't much I can do. Look at the analytics. I don't want any of that to affect the video surveillance, because I only have one volume. I can write everything into one volume across this entire cluster. With other systems like network appliance, various EMC products, they have multiple volumes, and those multiple volumes then say that I, as an administrator, have to worry about, is the volume going to fill up? Which recording servers are writing to that volume? How do I move that data without causing the recording server to fail? How do I grow that volume? What happens if a disk drive fails and the rebuild time is 18 hours and now another disk drive fails and it takes another 18 hours? And what happens if a third disk drive fails in that time? I've lost all of my video. What do I do? You want the fault tolerance of the Qumulo all the way through the end for critical operations. And I hope that answered your question. Please ask again or another question in the Q&A.
Yes, if anybody would like to ask a live question, please use the button raise your hand, and we can also you can have.
There are a couple, Marta, there are a couple from the Q&A. The same question was about our video surveillance partnership. Maybe Mike can expound on the Milestone and Genetic, and are there any others?
Let me just see. Okay, so Michael is answering the first one. Does Qumulo support any specific video surveillance software? Today, we are fully certified and qualified on Milestone and Genetec. We have also have customers that are using, well, one is looking at Bosch now, and that should work. We're just, certifying, well, we're actually verifying that right now. We also have, we have Panasonic, but basically any software that uses the SMB protocol should work perfectly with us. Now, I say that it could also use NFS, but I have never seen a video surveillance software today written in Linux. They're almost all written on Microsoft because of Active Directory and security.
We can add Honeywell as well to the software vendor. We sold 14 petabyte capacity for Honeywell CCTV requirements.
Thank you, Bharat. Yes, we did one with Honeywell. In fact, Bharat was the principal SE on that for a 14 petabyte system with Honeywell, and that works just fine as well. So, as I said, if they are SMB, we should not have any problem at all. Yeah.
One more question in the chat. Do we need a SAN storage for live database before archiving into Qumulo for Milestone?
No, no. So what Milestone does best is when, and let me just go to my slide here because that's a better picture. What Milestone does best is you could have in this, and let me just build it out a little bit. In this 1 hour recording, you could have SAN storage there, but there is no need because the way Milestone works is that if you write it to a local disk, if that recording server fails, then a failover recording server starts. And then when the recording server comes back, it merges the two databases in the local disk together and then transmits that all up to the Qumulo. So you will never lose video. The cameras will go to a recording server or a failover recording server. The two databases will be reconciled or put back together and then sent to the Qumulo. We do have some Milestone implementations, for instance, in Auckland, New Zealand, where we worked with HPE and all of the recording servers are in one data center and they use a Primera in order to do that first hour of recording. And then they go to a Qumulo cluster of 10 nodes of the HPE 336 terabytes. So it's about 2.8 petabytes of storage it's going to be 5,000 cameras.
So local HDD can do the job for live database.
Local HDD or local SSD. I tend to prefer SSD because it's faster, but you could also put in HDD and you would want to build that with a RAID of some kind, either RAID 1 or RAID 5 for that live database, and then do the same thing in your failover recording server.
Okay, thank you, Mike. So we have 1 more minute, or if you would like to stay for 2 or 3 minutes and have more questions, then again, please use the Q&A box. Or if someone would like to raise his hand and ask a live question, please do so. Otherwise, we are recording the session, so you will be able to reach out to us if you would like to have the recording. Also, we will be sending out some information on the VSS solution based on HPE. You can also reach out to your HPE colleagues within the countries, or if you're already familiar with us in the team, please reach out to us. We are very happy to answer any further questions or work with you on projects. So any questions in the chat?
Not that I see.
There is one raise hand. So yeah, Kim. Hang on. I just need to allow you to answer the question. Hang on. Anna, can you allow Kim to answer the question, to speak up? For some
Yeah.
reason.
And as soon as Kim can, if you can unmute yourself, you will be able to talk.
Yeah, that's
There you are.
basically the phrase that's used most in the last year or something. Could you please unmute? Sorry. Yeah, well, I had a question because I had a question from a customer, actually. Let's say one of the cameras is going offline. Would we be able to see that in our analytics part? Like if a camera stops working for some reason, and could we kind of, with an API approach, perhaps leverage that to do warnings for the administrators and stuff like that?
So in Milestone, they certainly have analytics for the cameras. You would actually get an alarm or an alert or an event, depending upon your terminology. And they would be able to tell you either through they call them not an API, but an SDK. It is an API where you could get an alert that you could programmatically then inform someone that the camera is out, and then they could take some corrective action. We also have a full API in the Qumulo, and we actually have a customer in Las Vegas that's taken the API from Milestone, the API from Qumulo, and kind of merged them together into one management console, so that instead of looking at the Qumulo for all of our analytics and the Milestone for all of its analytics, they merged them together into one web page so that their administrators can see all of the alarms and alerts from one web page. And that is entirely possible. We give you all of our analytics in our API, and Milestone does in theirs.
Perfect, thanks.
Sure.
Okay, so we passed the hour time, and I don't see any more. I don't see any more questions in the chat. So I would like to thank you all for your time and your patience and loads of interesting questions. And as I said again, thank you very much, Mike, for giving us the opportunity to listen to your experience on video surveillance solution. And yeah, if you have any more questions and if you would like to find out more, please reach out to us. Please reach out to your HPE partners. And we are happy to pick up the conversation, and wish you a good evening, good afternoon, and have a nice day. Thank you so much for joining us.
Thank you.
Thank you very much, everyone.
Nice day.